Hello everyone and welcome to yet another recreational programming session with Mr. Zozin. So today I decided to look at BC. Do you guys know what is BC? So it stands for Basic Calculator, right? So and it usually ships with pretty much any distribution of Linux. Does it stand for Basic Calculator? I think it stands for Basic Calculator, but don't quote me on that. So and I knew about this thing. Never used it, by the way. Never used it, but I knew about this thing. So another thing that I knew about is DC, right? So and DC is a basically desktop calculator, and it's actually a very simple thing. As far as I know, it exists since the first Unix times or something. Again, don't quote me on that. It's just like kind of a rumors that I heard. And it's a reverse Polish notation calculator, meaning that you kind of like write expressions like this. Right, so essentially by providing 34, I push 34 on the stack, and then 35, I push 35 on the stack, plus takes the first two elements on the stack, sums them up and pushes them back on the stack, and P prints the element on top of the stack. So, and it's actually arbitrary precision calculator, so it works with big numbers, right? It works with big numbers. I can multiply these things and I can print their value, and there we go. This is a huge value, so it's not limited to 64 bits. It's an arbitrary precision. So, and I also never used it. I kind of know it exists, so it kind of exists in this realm of like Unix utilities that I don't really care about. And I thought that BC is basically an improved version of DC. Right, so it's just an improved version. They all usually ship with Linux, and that's about it. So I think today I learned that to build a Linux kernel, you need to have BC. Right, and it's a mandatory dependency for Linux kernel. Like you can't build a Linux kernel if you don't have BC. And I built a Linux kernel before, but I built it on like a full Linux distribution, right, where BC was present, so it never really was a problem, right? So it was never a problem for me. But I accidentally learned that you do need this thing. And I started to look into that. It's just like, why do you need that? Like, what? You need a calculator to build Linux kernel? Are you out of your mind or something? So, and apparently they use BC for computing constants, right? So at compile time, they use BC to compute constants. And they here in the Stack Exchange, right? So they provided a link for the diff where they do all of that. So let's actually read what they're talking about. Replace timeconst.pl with BC script, right? And what's interesting, they were using Perl before to compute these constants, right? So now they're using BC script. So BC is a standard tool for multi-precision arithmetics. We switched to Perl because AKPM, I have no idea what it is, reported a hard-to-reproduce build hang, which was very odd because affected and unaffected machines were all running the same version of GNU BC. Okay, so that doesn't really matter. Right, unfortunately, switching to Perl required a really ugly canning mechanism to support Perl that is earlier than 5.8 installation, lacking the math big int module. Math big int. So not only they're using calculator to compute constants, they do need arbitrary precision, right? So because they use big integers. Can anybody tell me what the fuck is going on in Linux kernel? Like really, so they're using calculators to compute some sort of a constants, and they do need arbitrary precision calculator for that. Big long, yeah, maybe that's what it is. It was recently pointed out to me that some old versions of GNU Make had problems with pipes, subshells, and so on and so forth. It's not really that matter. So what's important is that they were using like a arbitrary precision and stuff like that. And let's take a look at it. And this is what it looks like. So this is a BC script. And I looked into that, and do you guys see what I'm seeing? Do you notice what I see? What the fuck is this? This is a literally programming language. This is not a calculator. Wait, I thought it's a calculator, right? I really thought it's a calculator where you put numbers and shit like that. And this is a fucking programming language. And it was just like, what the fuck? So it's why I never heard about it before. Like, it's a literal programming language, and now it kind of makes sense. So you can actually generate some, and they literally you can even print text. Motherfuckers generate C code with a fucking calculator. Mods, why do we have spoilers in the chat? Shut up. Anyways, so like think about it. In Linux kernel, they're generating C code with a calculator. And honestly, that raises the question, is just like, why don't they just use C to generate C? But I mean, again, they probably need like an arbitrary position and stuff like that. And that, in my opinion, only confirms that languages like Jai, they're kind of moving in the right direction, right? Because like I encounter this kind of shit all the time, right? So during the compilation, you want to generate some code. You always want to generate some code during the compilation if your project is sufficiently big, which Linux probably is, right? So, and we can clearly see that Jai is trying to emerge out of the C code base, right? So, but because C is not Jai, we have to use separate languages in here, right? So we have to use separate languages in here. So yeah, since it's a real programming language, right? So I looked into Wikipedia for this programming language, right? So I was actually open Wikipedia. So it does in fact stands for basic calculator. It's a basic calculator. And yeah, so it has if conditions, it has while loops, it has for conditions from C, and different operators like in C. Yeah, and there's some pieces of code in here. There you go. So here you can define a function. You can literally define a function. You can do some things in here. It's a literally programming language. So BC is a scripting language. Yeah, so it is a scripting language. And what I decided to do today is to maybe learn it, right? So because every time I need a calculator, what I do, I just open Python, right? So I just open Python. And if BC is actually more convenient than Python, maybe I should just use BC, right? So if I open BC, can I do 35 plus? Yeah, there we go. So this is literally Python, right? So it's not even like a stack based like DC, right? So it's a completely different thing. So apparently BC and DC are two completely different beasts, right? And I should not confuse them. But for some reason, I always thought that BC is kind of an extension of DC, but apparently it is not. This is actually useful for me. Well, you're welcome. Now you know about this thing. So first of all, I want to learn how to use this freaking language, right? So let's go ahead and maybe create some separate folder where we're going to explore this syntax stuff. So we're going to put BC in here. Let's do something like hello BC, right? So, and do we have any highlighting for BC mod, right? So there's no such thing as BC mod. Maybe I'm going to do list packages in here. So do you have BC? Okay, so it needs some time to actually refresh all the packages and stuff like that. So maybe BC mode. So there's a ABC mode, which is probably not what I need in here. That is kind of surprising, chat. That is kind of surprising. In Emacs, we don't have a BC mode, right? So what if I use Vim, set ft BC? Okay, so can I do define? Apparently, we have to use Vim, right? In Emacs, I don't see BC mode like by default in here anywhere. I don't see it in the repository. So apparently, Emacs users never use BC. Only Vim users use BC, so we're gonna be using Vim in this case, I suppose. I have not that much choice. So I don't know which theme I want to use today. So I'm using HaberMax. Maybe for the stream, I kind of want to use Dessert. So which theme do you prefer, guys? Which one should I use? So this is Dessert. It's kind of closer to what I use in Emacs, in my opinion, in terms of contrast and stuff like that. So we're gonna be using Dessert. So Torta, it's kind of it's too hackish in my opinion. I feel like a hacker. So if I wanted to feel like a hacker, maybe I would use this one. Yeah, so Groovebox, but it's not default one. That means I have to install it. So I don't freaking know. Okay, so we're gonna go with Dessert. We're gonna go with Dessert. So let me close this entire scheiße. I'm gonna go to prop BC. So, and I'm gonna open something like main BC. And I should be able to, there we go, I can do print, right? So I'm gonna do hello world. Can I now do BC, main BC? And yeah, so it didn't allow me to do this kind of stuff. So in the kernel, I did see print. Aha, it is like Python too, right? So yeah, you put a space. It's very close to Python, actually. It's very close to Python. So let's actually do it like that. So this is gonna be a space, right? So, and then I'm gonna do BC main BC. Look at that, hello world. And what's funny is that it continues executing, right? So it doesn't quit afterwards. It literally doesn't quit afterwards. And I wonder what's going to happen if, for instance, I'm going to use shebang, right? So I'm going to do user bin environment BC, right? So what's going to happen if I do something like that, and I'm going to make it executable, right? I'm going to run it, and that's what's happening with shebang. So I wonder, is there any way to make it quit out of this entire thing, right? So there's some options in here, maybe in some options, interactive, force interactive mode. Motherfucker, it forces on me. Why do you have a flag to force, right? So quiet, do not print a normal BC welcome. That's one thing we could do, right? So for example, yeah, so this is a nice one actually. I wonder if I can put it in here. As far as I know, you can't put too many arguments in shebang. Exit on the code. We're gonna try that at some point. So I remember, I remember that shebang was kind of limited, is that you can't really put 2 arguments in here. You can only put 1, and if you put the second one in here, it's not gonna really work. So it's kind of stupid, right? So essentially, it sees this space, and then it passes the entire thing at the end. So you have to use S of the environment, right? I never heard about it, by the way, surprisingly. I always thought it's kind of a limitation of shebang. So split string, process a split string into separate arguments used to pass ooh. So it's a limitation of env, not shebang. Or whose limitation is that? Who did the fucky wacky with shebang? Chat. It's a GNU. Oh, okay. So that means it's a env limitation. So it's an env fucky wacky. Damn. All right. So I always thought it's a shebang limitation, but anyway. So we'll probably have to do something. Thank you. I actually learned this thing, right? So I wrote Man, I wrote a lot of shell scripts with env and stuff like that, and I always thought that it's just a limit. Why nobody told me about the S flag? I wasted so much fucking time with this shit. Wait. You're welcome, thank you. So the S flag is vital, yeah. So S, yeah, there we go, and that seems to be working. Okay. So I feel like in BC there should be something to quit, right? So quit on print version, copyright in quit. So it's for version. So how this? Wait a second. It actually man page contains all of the things, all of the like syntax of the language and stuff like that. So you have to put halt in here. Okay, so halt. Okay, and then I can do something like main BC, and it exits. How about that? So if I now try to open this entire thing and put new line, can I put new line in here? Can I put? Look at that. Look at that. This is a perfect hello world. I can actually write software in a calculator. That's very convenient. I can do things with this thing. So it's pretty cool. All right. So, and here obviously they're just generating things and stuff like that. Yeah. So let me see. Can we use literally man page to learn about this language and just to learn what kind of things it's capable of doing? So variables, comments. Okay, so here is what they're explaining. The most basic element in BC is the number. Numbers are arbitrary precision numbers. Okay, so we can actually check that. Maybe, by the way, I can actually open it in one tab in here, and then open another tab where I can do experiments, right? So I'm using TeamUX, so that means I can actually do this kind of stuff. Okay, so this is going to be this one. Okay, so and this is the main page. This is the main window. Who needs Emacs, chat? Who fucking needs Emacs? You only need TeamUX, right? And Vim. That's it, right? So you remember how in Emacs there is a man mode, right? You don't need that. You can just open a real man. So, and you can always copy some text in TeamUX and insert it into Vim. There is a literal integration between man of Linux and Vim. I can literally copy paste text from one to another. This is very, you don't need Emacs. Like I don't understand people who use Emacs, like it's not needed. There's no place in the current market for Emacs. Anyways, so let's actually remove all of that stuff. What do we have? Numbers. So numbers are arbitrary precision numbers. This precision is both in the integer part and the fractional part. Okay, so this is pretty cool. All numbers are represented internally in decimal, and all computations is done in decimal. By the way, I wonder if BC depends on GMP. Does it? Okay, wait a second. So I probably have to which. Okay, so let's actually see what kind of libraries this thing depends on. Doesn't depend on GMP, interestingly. But maybe GMP is just compiled statically. For those who doesn't know, there is a thing called libGMP, and it's a library for arbitrary precision math for C. So it's also developed by GNU. So maybe this thing is using this library for arbitrary precision stuff. So it doesn't really depend on it dynamically, but maybe it depends on it statically, right? So we never know. But anyways, so let's actually go here. So so all numbers presented internally in decimal, and all computation is done in decimal. Okay, so this version truncates results from divide and multiply operation. There are two attributes of numbers: the length and the scale. The length is the total number of decimal digits used by BC to represent a number, and the scale is the total number of decimal digits after the decimal point. Okay, so that's understandable, right? So it's not a floating point, right? So you have to define the precision in here. So variables. Numbers are stored in two types of variables: simple variables and arrays. Bro, this shit has arrays. So both simple variables and array variables are names. Names begin with a letter followed by any number of letters, okay, digits and underscores. Okay, so this is a classical name for the variable, right? So it works like that in any language, by the way, right? So usually variables cannot start with a number because the lexer needs first character to identify the class of the token, right? So, and because of that, they usually don't start with digits, because usually numbers start with digits. So all letters must be lowercase. I mean, I guess it's fine for a scripting language, right? So it's fine for a scripting language. It's not a real language, right? So it's a scripting language. Full alphanumeric names are an extension. In POSIX-BC, all names are single lowercase letters. The type of variable is clear by the context, because all array variables names will be followed by brackets. Interesting. The type of variable is clear by the context because all variable names. Okay, so that's understandable. There are four special variables: scale, ibase, obase, and last. Scale defines how some operations use digits after the decimal point. The default value of scale is 0. ibase and obase define the conversion base for input and output numbers. Okay, so the default for both is 10. Last, an extension, is a variable that has the value of the last printed number. Okay, nothing particularly special. So comments, I suppose they're just like in C. Right, so the numbers are manipulated by expressions and statements. This is a classical programming language, right? So usually any imperative programming language is basically a combination of expressions and statements. So who knows what's the difference between expressions and statements? That's a kind of an interesting question. You can ask these questions on a coding interview, right? So tell me, what's the difference in a programming language? What's the difference between a statement and expression? So it's kind of a tricky question, isn't it? Right? So expressions has a value. That is true. Expression result is a value. Okay, so that's not a bad definition, I suppose. That's not a bad definition. Statement do things. Expressions also do things, unless it's a purely functional programming language, without necessarily returning value. Yeah. So statements ends with a semicolon usually. That's also a good definition, right? So I don't know. So I suppose you can say that the way I think about it is that program is or at least not even a program, but maybe a body of a function or body of a routine or procedure, is a sequence of statements separated by semicolons, which is also not always true in C, right? So we can say it's, okay, so body of the function is a sequence of statements. And statement may contain expressions, right? Expression can be statement, but a statement cannot be expression, exactly, right? So exactly. And it's a very tricky question because it all depends on the language, right? It all depends on the language. So in different languages, what is considered a statement, what is expression, is kind of slightly different. It's kind of slightly different. So it's sort of like I don't know. So it's this separation that language developers came up with to kind of separate sort of like a declarative style, declarative part of the language from imperative part of the language. Holy shit, did I just come up with a cool definition like for expressions and statements? Statement is an imperative part of the language. Expressions are declarative part of the language. Holy shit. Is that a good definition? I think it's a pretty awesome definition. Because that's what it is, really, right? So it's a declarative? Yeah. Not bad. It doesn't really tell you anything, right? So, but it's kind of interesting, thinking in the right direction. So one might think of statements as a meta language to manipulate expressions. Also not bad. So anyways, right, so this is a classical imperative language. It has expressions, it has statements. Since the language was designed to be interactive, statements and expressions are executed as soon as possible. Okay, that's interesting. So it's not like it's first parsed and then executed, right? So it's parsed and executed simultaneously, like lazily, I would say, right? So it parsed the statement, executed the statement, parsed the statement, executed. There is no main program. Instead, code is executed as it is encountered. Functions, discussed in detail later, are defined when encountered. Okay, so yeah, so that means there is no hoisting, right, like in JavaScript. A simple expression is just a constant. BC converts constant into internal decimal numbers using the current input base. Yeah, so I base and stuff like that. Legal values of I base are 2 through blah blah blah. So this is what I feel like reading this specific paragraph. Alright, full expressions are similar to many other high-level languages. Since there is only one kind of number, there are no rules for mixing types. Instead, there are rules on the scale of expressions. This is very interesting. Wait a freaking second. This is very deep. In all of these lame programming languages, you have integers, you have floats, and not only that, you have different sizes of integers, 32-bit integers, 64-bit integers. Not only that, you have signed unsigned integers, signed unsigned 64, 32, and then you have floats that are also 32, 60. Shut the fuck up. This language just has one type, which is a huge ass integer with arbitrary fucking precision, both in whole part and both in a fractional part. So there is no need to even distinguish different lame integers of different sizes or anything. There's only one fucking number. And it's even cooler than, you may say that in JavaScript, it's also like just a number. No. In JavaScript, number is actually, you know, limited by a size. This is not limited by a size. It can grow as much as it wants. Waste of memory, true, but I mean, the goal of this language is to be a calculator. What did you expect? Right, so it's already doing way more than calculator is supposed to do, so. JS number is a double, right? It's kind of double, but it doesn't even use all bits of double, right? So there is kind of interesting. So as far as I know, JS uses something called nan-boxing, which means that it stores some additional meta information about the type within bits of the IEEE 754 representation of the numbers. JavaScript is a mess. Don't worry about it. So it's a freaking miracle that we're still using this language for anything serious. So anyway, so since there's only one kind of numbers, there's no rules for mixing types. Instead, there are rules on scale expressions. That's understandable, right? At least on the level scale. Every expression has a scale. This is derived from the scale of the original number. The operation performed in many cases the value of the variable scale. Okay, so the type of the variable is more like a scale. In the following descriptions of legal expression, expr refers to a complete expression and var refers to a simple array of variables. Simple variable name. Okay, so this is how you refer to a variable. This is how you refer to an array. Okay, so that's very cool. Oh, you have, negation, increment, decrement, post-increment, and pre-increment, and stuff like that. You can do the usual stuff that you can do in C. Right, so you can do the usual stuff that you can do in C. So as far as I know, this one is very interesting. This is not XOR. So the result of the expression is the value of the first raised to the second. This is power. This is not XOR, this is power. So let's actually see, can I do something like 2 to the power of 69, right? So then I'm gonna execute that. I can do that, I can do that. But then what if I want to print a new line in here? So can I just put something like that? Is that something I can do? Okay, so on top of that, this language is rather intuitive. So the Python exponent, is it a Python exponent? As far as I know, Python exponent is this, right? So it's a double asterisk, right? So, and this one is XOR, right? So this one is XOR. This is kind of cool. So this is intuitive language, right? So far. Okay, so this is primary expression, right? So in parentheses, so we have assignment. So that means I can maybe do something like this. So I can just assign this entire thing like that. And if I execute it like this, it still works, right? So that's pretty cool. Can I just like do it like that? I can do it like that. So, all right. So I don't have to declare variables. I can just like, assign them and everything. So that's pretty cool. So variable, you can use the operator with assignment, just like in C, right? So that means I can do things like 34. Right, so this is a 34, and then I can do something like this. Honestly, it will be better to maybe use terminal, right? So then I can see the result and still see the code, right? So I kind of like it a little bit better. Right, so then I should be able to do something like 35, right? So, and then I do, where's my terminal? There you go, it's 69. So that's very close to Python, honestly, very close to Python. So relation expression, a special kind of expression. So this is like a real comparison, right? So this is essentially comparison. We can compare things. That's the classical thing. So so this is basically not really negation. Well, it is negation, right? Oh, and since there is no booleans, it's all zeros and one, right? So it's all zeros and one. Okay, that's pretty cool. So what else? Most C programmers would assume this would assign the result of 3 to the variable. What this does in BC is assign the values. Equal has a higher precedence than less. Oh my god, this is a nightmare that I encountered when I was, I think, implementing B. What this does in BC is assign the value 3 to the variable a and then compare 3 to 5. It is best to use parentheses when using a relational logical operator with assignment to parentheses. Why? It's a good question. They just implemented it this way. There are a few more special expressions that are provided in BC. These have to do with the user-defined functions and standard functions. They all appear as name parameter. See the description of the functions. Okay, so that's understandable. The standard functions are length of the expression. The value of the length function is the number of significant digits in the expression. What the fuck does it even mean? So excuse me. So if I do something like length, okay, so it's kind of cool that it highlights that. It's kind of cool that it highlights that. So length 2. So does that mean like this one still will return 2? So that's what it means, right? So it's just like it ignores the leading things. Okay, so you can use basically this thing as a logarithm of base 2. right? So it's a logarithm base 2. So read function will read a number for number. Can it read strings though, regardless of where the function occurs? Beware, this can cause problems with the mixing of data and program in a standard input. The best use for this function is in a previously written program that needs input from the user, but never shows program code to be input from the user. The value of the read function is the number read from the standard input using the current value of the input base for conversion base. It can only read numbers, but what if I want to read strings, right? Because I want to write something like this, right? So I'll say, hello, what is your name? Right, and then I want to read something, and I want to say, okay, so here's my name, and then I'm going to say hello, and then name. Right, so I want to do something like that. Is it even possible for me to write such program? Hello, what is your name? Alexei. It doesn't read string, guys. It doesn't read strings. What the? Why was it 10 though? Like, where did 10 come from? Hello 10. It's probably a hex, right? So this is because of the A or something. Man, this is so goofy. Holy shit. Okay, so. And on top of that, I probably forgot about the new line, right? So if I just do something like this, yeah, so hello 10. Cool. Scale. The value of the scale function is the number of digits after the decimal point, blah, blah, blah. Okay, so you can have square root and stuff like that. Okay, so that's understandable. Statements, as in most algebraic languages. Ooh. So these kind of languages are called algebraic languages. Provide the sequence of expression evaluation. Okay. In BC, statements are executed as soon as possible. Execution happens when a new line encountered and there is when a new line in an encountered and there is one or more complete statements. What is that a typo? Execution happens when a new line in an encountered. Maybe just encountered. I think we found the typo in the documentation. Okay. So due to this, yeah, probably maybe is a new line is encountered, right? So a new line is encountered. In fact, both a semicolon and a new line are used as a statement separators. An improperly placed new line will cause a syntax error. Okay, so that's understandable, right? So expression, so that's this statement does two things. So this is just an expression statement, the classical expression statement. String is printed to the standard output. Okay, so it's just printed to standard. I don't even have to like have print and anything. So the print statement and expression provides another method of output. The list is a list of strings and expressions separated by comma. List of strings and expression. And by the way, string is a separate kind of statement. It is separate from an expression. So according to BC, string is not a fucking expression. Well, I mean, what did they expect? This is a calculator, right? So, so okay, that's kind of interesting. So string is not an expression. All right, so, okay, compound statement. It allows multiple statements to be grouped together. So this is like C. So you can have if with an else, a bunch of statements. This is basically C. While loop, for loop. Okay, that's pretty cool. That's pretty cool. So, all right, you can have break, you can have continue, you can have halt. We know about halt. Return the value 0 from a function. Okay, so that's pretty cool. So I now understand the whole language. I know Kung Fu, I suppose. Right, so that's the entirety of the language, if I understood correctly, right? So there's also pseudo statements. I'm not really sure what they are. So these statements are not statements in a traditional sense. So it's a non-traditional statements. Okay, they are not executive statements. Their function is performed at compile time. It even has const export. It even has const. Okay, so limits prints the local limits enforced by the local version of BC. Okay, so the quit statement is read. When the quit statement is read, the BC processor is terminated. What's the difference between hold then? Regardless of where the quit statement is found, regardless of where the quit statement is found. For example, quit will cause halt to terminate. I don't know. Oh, but that's okay. Warranty prints a longer warranty notice. This is an extension. Okay. So functions provide, okay, so there's a little bit more in here. So you can actually define more functions and stuff like that. You can actually define more functions. So, okay, so let's give it a try. So I suppose the way I do that, I can probably do define greet, and that's how we do that. So here is the parameter, here is the new line, auto list, statement list. Auto list is an interesting thing. So I can define local variables in here, right? So that's probably what I can do. So this is something like that. And can I just do something like this? Will this work? And then I can do greet. And there we go. So annexy, and this is 10 and then 0. I wonder where 0 came from. Maybe it came from this function. This thing probably came from function, right? So if I do something like that, so right, Alexei, and it is, yeah, so that came from the function. So every time it returns a value, it actually prints that thing. Kind of interesting. So maybe there is something. How do they suppress that? Do they even suppress that ever? Maybe not. Okay, so this is the function definition. So auto list. There's a lot of stuff in here. It's like, why do I want to read that? Do I really want to read that? You know what I'm interested in is how do you define arrays? How do you define arrays? So they're kind of talking about arrays, but maybe we can find this thing, array, right? Arrays are specified in the parameter definition by the notation name in the function called the actual parameter full expressions. So kind of interesting. So let me see what we can do in here. So I know that I can do something like x69, right? So I probably can do something like this, and then I can print the whole thing. So this is x, and then yeah, there we go. So what if I say x069? Is that going to work? That kind of worked, and it printed 0, surprisingly. Right, that's what it did. But then if I try to print this thing, okay, so what if I do x10 for 20? Right, so and I try to print x0, it is 69. What about x of 10? It's 120. But then it raises the question, what's going to happen if I put like 1 in here? I never specified any of it. It is 0. But what if I put something that is above this entire thing? It is also 0. So you can think of an array as an infinite thing, right? So it is an infinite thing. So x and x are different. That's an interesting question. Wait a second. So can I do something like this, right? So if I do, and then I just try to do something like that. I probably have to print a new line in here so to separate them. But I think you are correct in here. You are actually correct in here. Because as they said, there is no ambiguity in here, right? So because, yeah, so they have separate namespaces. They essentially have separate namespaces in here. Okay, so that's kind of cool. Maybe, not really sure if that's cool. Kind of like feels a little bit of error porn, if you know what I'm talking about. Feels a little bit of error porn. Okay, so that's pretty cool. But what if I, like, how do I know the length of the array? Can I just try to print length of x? And that's really interesting because what it's going to do is probably going to print 4, right? So because it's going to assume that, that's very interesting. This is not what I want. I want to remove this part. So it's going to print 4 because this is the 4 significant digits in this number. But what if I want to know the length of the array? Can I say something like this? Yeah, you try thinking in the same direction. Syntax error. You cannot. You literally cannot. But I wonder if I can print the array by doing something like this. By doing something like this. You cannot. Okay, that's very interesting. So maybe there is some more information about the arrays. So if I do something like array, Variable names followed by arrays. Okay, so this is an array expression. Okay. There's not that much information about the arrays, honestly. There's not that much information, I feel like. Yeah, so I wonder if there's something online. GNU BC arrays. GNU BC arrays. Nope. Nope. Don't really see much. Okay, that's really interesting. Cool. All right. The real question is, it's cool and all. So try multidimensional. Okay. So let's give it a try. Multidimensional ones. So what about x3 by 3, 69, and then print 3 by 3. So what's gonna happen? It doesn't work. So it's a single dimensional array. Anyways, does it have an FFI? GNU BC FFI probably doesn't. And maybe if, well, I mean, it just redirected to libFFI. Okay, so maybe if it does have FFI, it is mentioned, yeah, it probably doesn't. It probably doesn't have a FFI, unfortunately, which means that we'll have to implement it. You know what that means, chat? Time to hack the source. Exactly. Right. So I think that's what we have to do. Right. So because on its own, this language is kind of boring. It's very simple. It is very simple language, right? So we just learn it within like a single hour, right? So I kind of roughly understand what this language is all about. Maybe I'm going to start using it at some point. But yeah, so let's actually hack its source code. I think it's going to be interesting. So where can I get it? So here is just a manual, but maybe if I go somewhere here, I'll be able to take the source code of this entire thing. Reading GNU code, let's go exactly. So it's taking a little bit of time to open it up because maybe, yeah. Damn. So it was also taking a little bit of a time to open this thing in the first place. All right, so I wonder if there is a way to just download this entire thing. Yeah, connection has timed out. So we'll have to come up with a different way. All right, so I've got an idea. Let's, GNU website sucks. I think it just basically, it's either blocked in Russia or Russia is blocking this website. It's one of these two. So let's make a small break, chat. Let's make a small break. I'm gonna make a cup of tea. And on a break, right, so we're also going to just try to figure out how to acquire the source code of BC, right, so, and then we're going to try to hack the source code, right? Maybe I can acquire it from the package manager of the, of Void or whatever. Oh, it's dead. Really? So GNU is dead. Did we DDoS it? Maybe we DDoS it, right? So everyone just tried to visit this page and it's like... all right, so anyway, let's make some break. I'm gonna make a cup of tea and we're gonna just try to come up with something. Oh, by the way, thank you. So FTP works. Okay, so maybe we're not gonna do a break. No time for break. Nah, it doesn't work. It doesn't work for me. It definitely doesn't work for me. Though I've got a couple of ideas, actually. Can I SSH into your mom? Is your mom? Okay. What if I get it into your mom? It's not even accessible through your mom, unfortunately. Okay, so we're making break then. So I was thinking that maybe I could just download it onto your mom and then, SCP it from your mom, right? So because like I don't have a VPN right now. So yeah, in Italy it doesn't work too. So I think, yeah, so apparently GNU is down. Guys, we DDoSed it. Sorry. GNU, okay, so it's just probably generally worldwide down. So yeah, sorry, Richard Stallman, we DDoSed it a little bit. Oopsie doopsie, oopsie daisy. So let's wait a little bit, right? So let's make a cup of tea, and after that we'll see what we can do. Maybe there's some mirrors from which we can download the source code. Anyway, We are back. So I found a mirror from my comrades at yandex.ru. So let's actually download the BC source code from there. Let's fucking go. So maybe I'm gonna go through Emacs. So I'm back to Emacs. So I'm gonna do wget. Hopefully I'll be able to download. Okay, there we go. So that was fast because it's close, right? And let's actually unzip the whole thing. So hopefully KGB is not gonna pull me. So there's a configure script. Let's do configure help. So what do we have? So what kind of features do we have in GNU BC? Not that much, right? So the standard shit, nothing particularly special. So do I want to actually install it somewhere? Let's actually try to set the prefix to something like home opt bc, right? Let's install it locally in a home folder. Let's fucking go. So there's a bunch of yeses, there's some no's in here. So checking about the course compilation, Minix config. We don't have support for Minix. lib.h, no. What the fuck is lib.h? X open source should be defined, it is not defined. Apart from that, everything seems to be fine. Let's try to compile this entire thing in 16 threads. Done, and it failed like a motherfucker. All right, so what happened? Let's try to understand. I don't understand what happened. I didn't even see an error. Chat, do you see an error? It exited abnormally. Error 127, waiting, making for not found, making for not found. What the fuck is it making for? Okay. Query or s making for. Do you guys know where I can find this thing? It makes info. Okay. So Linux make info, maybe void. Make info. What is make info and how do I get it? Good question. I have the same question. Command not found. Text info. Obviously, the utility make info is located in a package called text info. Okay. Fair enough. Fair enough. So do we even have xbps query rs text info? We do have it. I have a bunch of crap in here, so my package manager is completely fucking broken, but it is what it is, and it isn't what it isn't. Okay, so can I now just I can't do that. xbps install text info. All right, let's fucking go. Installing. So it is done. It is done. So I can probably do something like which text info and no well, make info. I'm sorry, I'm an idiot. Make info. Yeah, it doesn't exist. It does exist. Okay, so let's make it in 16 thread. And it's done, right? So look at that. It's finished. It did its thing, and maybe we can try to do install in 16 thread. So let's take a look at opt. So what do we have in here? So here is bc, and here is the bin, and there's it also. Wait a second. So the DC and BC are related, and they're part of the same code base apparently. So. Okay, so and there's two executables in here, fair. And there's a share, there's info pages, okay, and there's man pages, but apart from that, this is just an executable, right? So do we even need to install anything in here? I feel like we don't even need to install it. We can probably try to find the executable with the name BC right in here, and here it is located straight up in here. So it is located straight up in here, which is kind of cool. So I can try to run this entire thing. Like we don't even need to install it at all. We can just try to run it directly. BC, let's freaking go. Print. So hello chat. Right, and probably put a new name in here. There you go. So 34 plus 35, and there you go. So here it is. And what's the version that I have installed in here? Oh, it's even newer. Look at that. It's even newer than whatever I already have installed. That's pretty cool. That's pretty cool. So can we hack it? Can we hack this entire thing? So let's actually try to find where the print function is defined. Right. So as you can see, we already know that there is a print function somewhere, like a print, and you can put hello world in here, and so on and so forth. The fact that print function exists, what that means? That means that somewhere in the source code of BC, there is literally a string literal that says print somewhere. Maybe it is used in the condition, maybe it is used in strcmp with a name like this, or maybe it is a part of some sort of an array of names or something like that somewhere, but it probably does exist somewhere. So the way we can try to find that, we can literally try to grab string literal print in the entirety of the code base, and it doesn't exist. I'm surprised actually. Damn, so the code base is fighting back. GNU, by the way, GNU moment. So it is not, so there's no just a string literal print. Just a string literal print does not exist. Thank you, Stallman. Okay, so what if it's not exactly print? What if there is a little bit of like a variation? Maybe there's some stuff in here, some stuff in here, but somewhere in the middle, it's kind of like a print. Okay, so that's very interesting, So this is documentation, we're not interested in that. This is just examples and stuff. This is config and everything. So this is prints and stuff like that. Okay. Oh my God. Do I understand correctly what the fuck this thing is? Is that a YAC file? Fuck, it is using YAC. It's a parser generator. Motherfuckers using YAC for... Dude, TCC implements the whole freaking C standard and doesn't use any YAC. Does it? I think TCC doesn't use any YAC. I think they're like literally parsing manually. Oh boy. Okay, so how do you do shit? So print... Because of that, okay, so my expectations about this code base were wrong. So that means there's somewhere more like something like this, right? So it's a literal, but it can use single quotes because it's not in C, right? So it's not in C, it's in YAC. And that's kind of correct, but all of that is more of a comments in here, right? So it's more of a comments. So there's a token variant hold print, and it's capitalized like that for some freaking reason. I'm not really sure why it is capitalized like that. So let's actually try to use capitalized print in here, hoping that we can maybe find something. So I want to find a mapping from this identifier, right? So this is a print statement. Yeah, so it's a Steve warning print statement. Print 288, yeah, so there's a print 288. But I want to see, like, where is the mapping from just this token to print? Because they do say this is print, but this is inside of a comment. Right, you see? This is inside of a comment. And I'm not really sure, like, that familiar with YAC, so I'm not really sure like how to properly read this entire thing. So there's probably Lexa somewhere. Yeah, that's true. There should be a Lexa somewhere. And what is where the Lexa is located? So we can go to here. So this is Y. So there's something like Lex. No. So maybe if I take a look at this stuff, so print, so what is it token type, and this is print. I wonder if I can break this code. Is this code generated? I don't think this code generated. So the Bison parser interface for YAC-like parsers in C. Do not rely on features that are not documented, blah, blah, blah. Okay. All right, so let's try to recompile the whole thing and maybe we'll be able to. It didn't even fail. So ACO. So I can't even recompile the whole thing properly because I don't have AC local. So scan L. Oh, okay. So thank you so much. Scan L. And the print. Here is the print. Ah, okay. So yeah, that's what it is. And what is this file even? What is this file? This is a file part BC. Scan L. It's a flex. So it's using a flex description. Right. And so this is that. Return print. And so on and so forth. So I'm thinking how exactly we're going to be actually approaching this entire thing. How does this relate to Python, Lex and Yak? Does Python have Lex and Yak? Import Lex? I don't know. Okay, so I want to be able to rebuild the whole thing. Right, so I want to be able to say, okay, rebuild the whole stuff, but as you can see, I did some modifications to the code base and it didn't change anything. You know what I want to be able to do? I want to be able to know what kind of changes did I make, right? So because of that, I want to get rid of this whole thing, right? And I want to unpack the whole source code, but then I'm going to do git init and I'm going to turn it into the git repo. Right, I'm going to just do ready, set, go. There we go. So then if I make any modifications anywhere, so scan L, so print, let's actually find the capital print. For example, yo mama, right? So then I go into git diff, I can instantly see what kind of changes I made to the scores and then I discard them. Right, since I just got a tarball, I don't have a Git repository, so I just created a Git repository specifically so I know what I changed. Okay, so let's try to maybe do configure. We're gonna reconfigure the whole thing. And I'm not gonna set the prefix because we don't need to install it anywhere. So, and then I'm gonna rebuild the whole thing now. All right, so we can take a look at so it introduced a lot of garbage in here, and now I can see all of that garbage here as well because I'm using like a repo. Git init, so it modified some stuff that is already in here, so that's kind of it's kind of cool idea, right? So just to see the deviation between these things. Yak and Flex stream soon, I guess right now, right? So because now I have to learn Yak and Flex. I remember using Yak and Flex only once when I was in uni just to test it out, just to try to understand what the fuck it is, but I don't remember much from that time, so yeah, I'm not quite sure how to use all that stuff. Anyways, what I want to do, let me go into here. So this is going to be scan L, and I literally want to change the print into your mama, right? Just to test, do I understand correctly how this entire thing works? Do I understand correctly? So if I try to rebuild the whole thing now, will that work? So did it do anything with the scan? All right, so that's pretty cool. So it detected that I modified scan L, and it recompiled the whole scan thing. So now it is working like that. Right, so now if I try to do something like BC, right? So do I have BC? Let's find, I'm probably in the wrong folder now. Yeah. So BC, and I can try to do print hello world, new line, syntax error. Now, your mama, hello, it works. I just replaced print with your mama. So that means I established the dominance in the source code. Right, so I made some modifications. Those modifications got reflected in the behavior of the program, so I got control over the source code. OpenAPR, they're not using GitHub, by the way, so... Making contributions to GNU projects, by the way, chat, is an insane pain in the ass you won't believe. So first of all, you can't just submit a pull request like in GitHub. You need to submit a patch to their mailing list, and it will very likely get ignored. And if it's not gonna get ignored, you're gonna probably have to do some paperwork to transition the copyright or whatever, right? So some copyright work, I don't really know. The use email, yeah, so they use email patches, right? So it's license matches, it's a huge pain in the ass, right? So just a mere mortal cannot easily do that. So, and yeah, Which is good, by the way, which is good. So because my GitHub is a fucking circus, right? It's just like quite often I just open my GitHub, open my notifications, and just close them. And it's like, anyways, so here is your mama. How are we gonna be doing this entire stuff? I'm kind of curious. When I was trying to do something like this, so it was AC local. Maybe this is something that we have to install, right? Do we have to install that? Let's give it a try. Super quick. HexBPS query rs AC local. Okay, so yeah, so it's not a all right, so void AC local. Where can I get that? AC local command, gigs for gigs, by the way, gigs for gigs. So autoconf, you think it's an autoconf? Let's try to install autoconf. Autoconf, okay, so let's fucking go. Autoconf is already installed, by the way. AC, well, I do have AC, wait, it's AC local 16, and it was complaining about which AC local? It wants AC local 17. Okay. I think GNU keeping people out of contribution is good because nobody should be forced to deal with the typical GNU code base. It's this is the classical autoconf pain. Okay. Let's download the same version as we have installed in Void. Let's download the same version. Okay, so wget. So because I think, yeah, so that's the version I have. Let's go. Let's do git init, like so, and let's commit everything in here. Ready, set, go. Let's go. Okay, so configure. Make 16. Alrighty, and so what do we have? If I try to do make B, what do you say? Now it's below. So just symlink. I guess it's a good idea. Oh boy. All right. So if I'm gonna be symlinking, I might as well symlink it like this. So let me, which AC local, right? So it is located in here. All right. Oh boy. So let's go in here, grab AC local. So lns, I don't quite remember, by the way, ln targets. So the first is target, ln s ac local, maybe here, ac local 117. Right, so it wanted 17 if I remember correctly. Right, so if I try to take a look at that, yes, so it is redirecting. This one is not even a symlink, by the way, which is kind of weird. Maybe, well, we'll see. Maybe I'll have to redirect it to... Oh, fuck. Did I... Well, no. Okay. So, everything's fine, chat. Everything's fine. All right, so... I didn't do hard link, by the way. I put S in there, so this is S, this is a symlink. Did it go into a loop? How did they manage to overcomplicate a simple fucking calculator? I have no idea how they managed to do that, honestly. But somehow they managed to fucking do that. Alright, so I suppose doing something like B is not feasible, and if something is not properly picked up and not rebuilt, we just have to suffer through that. I guess that's kind of the point in here. How even is it looping? I have no idea, bro. I have no idea, honestly. So So I'm gonna try to configure the whole thing. It's such a freaking simple language. It's simpler than C. It's simpler than C, yet they managed to somehow overcomplicate it. Do they do that intentionally? Fuck, I did B again. I'm sorry, I didn't mean to do that. Git clean of DX. So yeah, I'm pretty sure this is some sort of like a job security or whatnot. It must be. It must be some sort of a job security. All right. So how are we going to be approaching this entire thing? So the problem is, I want to be able to link with Raylib. If I'm going to be doing that with Raylib, yeah. So make B is running configure again. Yeah. So that's what's going on. So do we link with math library? Do we link with math library anywhere at all? Like, does this thing even exist? Huh, that's very interesting. So it couldn't find the math library anywhere in here. Dang, this code base is more complicated than I thought. It implements math itself. Yeah, that's understandable. That's understandable. So let me see. So we have scan. Where is the main? So here is the main. Here is this sort of like a. Where is the main input? Yeah, here it is. Here is the main input, and so we initialize the storage. This is a very old style of Emacs. It integrates with Emacs or something. It's very interesting. So you do the parse, then if compile only print fn. That's very interesting. Why parse? Okay, so, and I can't even do anything here. Let's try to, by the way, find all the files with the name that ends with C and H. Well, yeah, I forgot to put this thing. Okay, so here are all the files in here. Then I'm gonna do e tags, right? So this is e tags. And then I want to jump to this specific place. Which is tags, and it couldn't find why parse. Okay. So here it is. So why parse, and it's forward declared. But here is the implementation, right? So I suppose what is going on in this specific function is that as they parse the thing, so this is this generated? I don't think it is generated. Wow, this is cancer. It feels generated, by the way. It's bison performity. Okay. So it is generated. Yeah, so it is fucking generated. So if I want to make any modifications, I probably have to make them in BCY. Right. In BCY, because that is not for, yeah, so it's 2000, well, 2000 lines of code is not that much, but, oh, they even have a mapping to where all of that is happening. Okay, so apparently, yeah, we have to modify this file if we want to do anything in here. That's very funny. So if you encounter continue, so what is that? Statement warranty. Aha, and here you call different functions. All right. I wonder, can I do something interesting in here? So I suppose essentially here are different statements, right? Here are different statements and they are according to the documentation. So can I add a new statement in here? Yeah, let's actually go ahead and do that. So there is a print in here, and here are different things. Warranty prints, let's put your mom, let's put foobar, right? So let's actually put foobar in here, like so. And we need to do scan L. Where is print? Okay. Foobar, return foobar. That's what we're doing here. So in the print, that's the only place where we kind of encounter this entire stuff. Okay, so and this is foobar, and somewhere we have a print, and if I'm gonna do something like this, you encounter foobar, and as you encounter foobar, so this is st_warn, right? So which is a, I guess it's just like it says that it expects something in here, right? It expects a print list. So I want to see maybe halt. So is that the only, yeah. So where is the halt? Yeah, here it is. Generate H. There is a quit and generate H. Okay, so what if I grab my foobar and move it closer to halt? So what I want to do is maybe have a printf in here, something like this. So can I just do something like that? New line. Yeah. Maybe let's put it like that. Foobar. And it tries to like indent it, and I'm not sure if I like that. I'm really not sure if I like that, but yeah. Okay, so can I try to rebuild the whole thing? So it complains about some things. So POSIX reserves type for non-terminals. So this is a bunch of warnings, but I don't think they have anything to do with what I'm doing. Okay, so scan L, and this is foobar. All right. So now if I do BC foobar, okay. So yeah, that's cool. So what we can do, can I scan L, init window, all right, so init window, I mean, that's the only way I can see you can introduce like a bindings to Raylib. You can print, as far as I know, you can have chunks of C code in Yak grammar, and they're going to be literally embedded there. So if I understood correctly, you can run any C code. Yeah, so you can run any C code there, and that means you can actually do Raylib stuff, right? So if you properly link with it and everything. Okay, so this is scan L, and let me find the Yak stuff. BC, BCY. So foobar, so init window. Where is the foobar? Init window, and in here we're gonna do init window. We're gonna actually hardcode this entire stuff. Hello from BC, maybe even GNU BC. So we're gonna do something like that. So let's try to compile this entire thing, and obviously called object is not a function. Oh, this is weird. What the fuck is that? Init window. And is that this is a different name. I see. So what that means is that maybe we have to call that thing differently because there is a collision between functions and names. All right, so in a scan L, so this is the, let's say that we're gonna encounter init window, and this is gonna be init window like this. So this is the token, right? This is the sequence of characters. This is the token, and init window. This is the token in here, and init window. This is the token, and for this token, we're calling this function, something like that. I guess there's a bunch of collisions going on. Okay, implicit declaration of the function, blah blah blah, blah 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 blah. So we probably, yeah. So here's a bunch of includes, and there is a global function, global.h, and what is that? It's a file part of BC, so the documentation what it is a global variables for BC. I wonder, global, global, more like global.h. Okay, global.h is actually this thing. Do we have any includes in here? Do we have any includes? We don't have any includes, unfortunately. Okay, so proto. Okay, let's take a look at proto.h. Fuck, I can see shit. Do we have any include? Here they are. So, proto function definition for external this is perfect, honestly. If this is for external functions, that means that we can put Raylib in there. In fact, we don't even have to include Raylib, I presume, but we can try to. So we can always do something like Raylib.h, and obviously it's not going to work. Because like we can't find that. So interestingly, like we need to modify the command line thing. I need to inject include path to Raylib somewhere in here, but it's not possible to do that directly in a makefile because makefile is generated by autoconf. So we have to reconfigure things, I suppose. Right, so it's generated by automake from, yeah, so this is what's going on. So it's generated from makefile in, right? So it's generated from makefile in, and generated by automake from makefile m. Okay, so but it's not particularly helpful. So this process, okay, so this is a subdirectories. So that means maybe we want to do that within the subdirectory. So this is m, cpp. Ooh, did I just found it? Bro. So libbc, can I literally add something like home, opt, and then in here we can do something like Raylib. Where is the Raylib? Yeah. Include. Can I do just include? Am I getting the hang of autoconf? Disgusting. Alright, so can I just rebuild the whole thing? No fucking way, bro. I nailed it. Wait. Bro, I know autoconf. Holy shit! I'm really getting the hang of it. Like I understand what the fuck is like is supposed to be in here. Okay. So and how do I link now with different shits? So libs. There should be something with libs and whatnot. Okay. So there's this libs thing, and I don't see defined properly. So I'm not really sure. Can I do libs equal to like L? Like search for the libs in here, and just link with lib raylib.a. Okay, so no rule p. What the fuck are you saying even? No rule to target p defined by bc. Okay, so can we just not do that? So am cpp. CPP flags, where are the... Oh, okay, so... so FC bootstrap SBC. I'm thinking maybe I could just put the hack in here and just... Oh, remove P? Oh, did I put it accidentally in here? Wait, just a second. Make file am. So modified. Oh shit, I did. I'm sorry. So libs. Okay, so that was fine, I suppose. Oh fuck. Oh shit. Oh fuck. Oh shit. It worked. Absolute budgeting. I can run Raylib even on a fucking calculator. Even damn. So why it's still going? I think I know why, because it waits for the next thing, I suppose. Raylib, yeah, so Raylib PC. Honestly, adding Raylib bindings for BC is kind of a cancer, because, like, what do you have to do? You have to add a statement for each individual function, which is, I think it's not ideal, honestly. I don't think it is an ideal way of doing this way, especially considering that BC just has expression as a function. Doesn't have a proper CFFI. I don't see it right away. Honestly, I don't really see it right away. So external, we can try to maybe do something like external as you suggested in here. So this is not a bad idea. I think it's an interesting idea. Yeah, so we have to come up with something better than this. So init window, but I mean, we kind of already achieved. So window achieved. So any %, so which is kind of cool. We need to think how we're gonna approach this entire stuff. So this is the statement, and statement is an expression, right? So you have different sort of expressions in here. So, and expression, comparison in expression. So this is a warning. So, and I suppose this is how you check different kind of expressions, right? So that's how you do that. It probably has something to do with an expression. So comparing parent. So do you have fun call function? So there is a function. But this is a function definition. This is a function definition because it has the keyword define, opt void, and blah blah blah. So, but maybe there is other function. Void function, so there is a return. Okay, so expression, right? So named expression, expression and expression or not expression. So this is kind of like very similar to documentation that we were reading. Okay, so this is just the different kinds of expressions. Nothing named expression. Okay. Oh, chat. Name opt argument list. You look up funct. And where do you get funct though? So I think this is where we have to do things. Okay, so if funct f void expression void, otherwise that. So generate gen string. I'm not really sure what the fuck is all of that means, but oh yeah, I suppose you looking up function in funct variable, which is probably some sort of a global variable. Yeah, so let's try to maybe find it. I feel like this is some sort of a global variable of functions. Where is it? Okay, so this is a yeah, it's an index. So that probably means we need to find the lookup function. So where is the lookup function? Name kind. So it's in. Okay. I see. So probably what we are interested in is more something like this. Can I look for that? Oh boy. So integer. So all of that is proto. So it's probably defined somewhere in a different. Bro. Are you for real? Where is implementation? Where is implementation? Okay, can I... Am I going crazy? Is it implemented somewhere in a different place? Okay, so there's this thing. Bro, fuck GNU, fuck you. Fuck you. Fucking declaration has int and name on the same line, but definition puts them in different ones, and I couldn't fucking grab that. Oh my god. But, it is fucking evil, but I mean... anyways, alright. So, and... yeah. So, essentially, what does it return to you? What does it return to you? Name kind array if a name kind funct. So so it looks up the name, use math. That's a very, like, what the fuck is this style of indentation, right? So this is a tab and this is spaces, so they probably set the width of their tab to 8. Psychopaths. So all right. Okay. So if name not equal to that, we just free and return next function. So is that sort of like, where is the loop? I was expecting some sort of a loop, honestly. So name kind. So what I expect like lookup to be is just like some sort of a loop which looks up in the array at with the kind this or something like that. I don't see that. That's kind of weird. So name kind, so this is a switch, it's a function of function definition, and ID, I'm still not sure. Oh, you find ID in the name tree. So an ID, it's an ID rec. Okay, ID rec. Do you have util? You find the name, and then that's, okay, that's kind of weird. But I think I kind of understand what you're trying to do in here. And then you just return f name, and it's just an integer. So I'm just thinking, can I simply have a hack in there? If name is equal to init window, right? If name is equal to init window, just call that function. But where should I call that? That's the real question. Where should I call that? If I go to BCY, so we looked up that function, and it gives us the index. And if inside of the functions it's f void, right? If it is f void, it's an expression void. Otherwise, it's expression regular or whatever. 3, I have no idea what the fuck is that. Otherwise, generate gen string. And what the fuck is a gen string? Okay, so it generates this, like, it generates something. I'm not really sure what the fuck it generates. So yeah, it's really weird. It's really weird. Maybe one of the things we can do in here is, by the way, look at the generated code and just like find, yeah, here it is. So because that's the generated code. So it saves that into gen str. And it just generates a string. So what is the generate? What is gen string? What is this function? Let me see. Right, so is that const? Do we have? Okay, so there's probably some space. And of course, the declaration has void on the same line, and the definition hasn't. Anyway. So compile only and then load code. Very interesting. So there's a function load code. Okay. So load code. All right. The same shit. The same shit. Here is the code. What am I looking at? Is this some sort of a bytecode? Cell instructions have integers in the code. They are load code loads code into the machine. Ah, this is a byte code. Chat, I think this is a string of a byte code. I think that's what it is, literally. Breka. All right. Okay. But it doesn't feel like... Why is it just str? If I dereference this entire thing and take a look at 10 of them. So str, okay, so let's continue and bring the code one more time. Continue. Let's display the code. Okay, so it's colon, continue, k, 4, colon, plus, w. Okay, 34 multiplied by 35. K, 34, colon, k, 35, colon, multiply, w. Single letters as bytecode. I think that's what it is. So what it's doing, as you call a function, it generates IC. So that means we can actually use that trick, believe it or not. I think we can use that trick that I want you to do. It's just that we have to be, yeah. So one thing we want to do, so this is the string, and in BC, let me find this code specifically in the generated place. Okay, so this is a string, right? So we already established that lookup accepts a string. Okay, so that's cool. So which means that in here, what I can do is have some sort of a hack. So essentially, if one strcmp is equal to, and I hope it is null terminated, init window, right? If it is init window equal to 0, I'm just going to be calling init window 800 by 600, but I also need to be able to take the parameter list. I'm not really sure how I can grab it, but so this is going to be a hello from expression, like so. And after that, I have to kind of skip this whole block, right? In the generated code, where is the, okay, so this is a case, which is cool, chat. So that means, right, look at that. So the whole block in here is within the case, which means that I can quit the whole block by putting break in here. Damn, that's cool. All right, that actually makes it easier. That actually makes it so freaking easier. All right, so let me try to recompile the whole thing. So we probably need to get rid of the statement, init window statement. So let's do git clean fdx, right? So, and let's take a look at the changes that we have in here that we've made so far. Right, so there's a lot of stuff in here which is just like a regenerated thing. So scanl, okay, so I want to get rid of the scanl, right? So no scanl is allowed. In BCY, we added this statement, right? So for the init window, we don't need that anymore, and we don't need that thing anymore. So init window is not a thing at all. So scanl, I'm going to revert the whole thing. So init window is not in Alexa. it is not in Alexa. And then init window is only within the expressions. That is very cool. So now it is purely an expression. So let me try to recompile the whole thing. I'm in the wrong place, by the way. This is because I need to reconfigure the whole thing. Let's reconfigure it. Okay, so I'm gonna do make. So this is the make, and that's pretty cool. So it's building things. I should have actually used more threads, but that's fine. Okay, so there is no, as far as I know, there is no init window anymore. This is it's still available. Okay. Any name is kind of like, it's a variable, I forgot. It's a variable, and any variable by default is 0. So I should be able to do something like init window function call. Syntactic error, fuck. Interesting. So it was not, yeah, it didn't work properly. Did I, was I supposed to actually put something in here? That's a real question. So because there's this thing, maybe I was supposed to also sort of mark window without parentheses. I don't think so. This is a function. Not window. No. It's a thing. So maybe what I was supposed to say is that this is a regular function. You see, I'm not sure what this variable is. BCC. All right. So yeah. So you probably have to say what kind of expression that is, expression void or expression regular or whatnot. Or maybe I have to say that it is a void. If a function is a void, it probably doesn't return anything. In our case, init window doesn't return anything. So I think what I have to do in here, I have to do this thing. So because then it tells the parser, that it is sort of like the void function. So they also do this, you know, freeing of the arguments. So maybe we're leaking a little bit of a memory, but that's totally fine in my opinion. Isn't it prohibited to use uppercase in BC? Ah, fuck. Okay, you're right. Okay, so let's try it like that then. Yeah, thank you so much for reminding me. I completely forgot. Yeah, so init window, and it's probably not going to work because it's a variable. But now, if I do init window, fuck yeah, thank you so much. I forgot about it. All right, cool. So I don't even need to do the other things. Funnily enough, how are we going to be organizing the event loop and shit? Yeah, so if I try to else if strcmp, now I can do this kind of shit. Absolute budgeting, I know. Right, so kind of interesting. So we can try to do like a begin drawing equal to 0, and I can just call begin drawing like this, break. This one, so this is end drawing, and here we call end drawing like so. And so I want to actually kind of like draw rectangle. So draw rectangle. Okay, so and in here we're gonna hard code all of these things. Draw rectangle, and it's going to be just like I'm literally hard coding because I'm sort of incrementally creating the bindings for this entire thing, and this one's going to be red, and this is just a break. All right, so let me see if that's compilable at all. It seems to be compilable. Okay, so Raylib BC. So when what we want to do in here is just init window, right? So this is init window, then begin drawing, then draw a rectangle, and end drawing like so. And then we're not going to do any hold or anything. All right, so because I wanted to sort of hang and show me the rectangle. So let's do BC, Raylib BC, boom, 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 boom. I want you in my, okay. So that's pretty cool. We can't really close that, right? So we can't really close that. But I wonder how can I now get different parameters in here? So how do we even parse the parameters? Because all of that is obviously hard-coded. I want to be able to unhard-code all of that stuff. So this is OPT list. So as we find the functions in here, yeah, so this has something to do with parameter 3, right? So this has something to do with parameter 3. So we get the params, then we set the gen size. The fuck is that even? I'm not even sure. And then we free the params. So I suppose we're generating the bytecode for this machine that we're generating in here. So that's what's going on in here. We're generating the bytecode. So let's take a look at the generated codes. BCC. Okay, so maybe I need to revert that. Yeah, there we go. Okay, so it's kind of interesting. So here is the original code, and this is the generated one. And we do call this string, and it is a value. And I wonder what is a call string. What is a call string? Would be kind of nice to maybe break into here. You know what I'm saying? Would be kind of nice to break into here. Yeah. So, or at least maybe into here. Right, at least into here. What's interesting is that there is this thing. So there is a source mapping, right? So you can print against string. Oh, that's true actually. That is actually true. So I can do something like a call string, and yeah. So let's try to do that some way here. Printf. That's a good idea. All right, I was about to do the debugging, but that might be even better. That might be even better. Okay, so this is compile. Seems to be compiling. All right, so let's do init window, and I want to do something like 800 by 600. Hello. All right. Syntax error. Nice. And I know why, because string is not an expression, and you can only pass Oh my god! Since string is not an expression, the only place where you can pass a string as a parameter is a print, because print is not a function either. Holy shit! Oh my god. This is such a goofy language. Oh my god. So why didn't they make string an expression? I think I kind of know why. Because if they did, that means you would be able to put strings into plus operation. Because BC is a calculator. Exactly. Oh my god. Okay, so that means it's literally impossible to do something like this. Like, you can't do something like this at all. Like, this is not a thing. Oh boy, like, because I can't pass a string, so it can't have proper Raylib bindings, unfortunately, unless you encode the string as a big number. Holy shit. Wait a second. Wait. Nah. Well, I mean, it's kind of difficult from the user perspective. It's kind of difficult from the user perspective. Oh, we can go back into hard coding like a new kinds of statements for each individual function in here, right? So I don't know. But anyway, so one thing I wanted to do, just a second, init window is, what if I just provide these things? Oh, and fuck. Yeah, I can't see anything in here, so let's maybe do something like abort. Because I want to see something. Init window. Okay. 0, 0. Fascinating. Absolutely fascinating. So I think it is something for the bytecode of their machine. I think that's what it is. So we should probably try to access this 3 thingy directly. So let's actually try to find what is call string. I'm going to assume it's in utils. Here it is. It's an arg list. Okay. So that thing is literally an arg list. And what the fuck is an arg list? What is the definition of arg list? Where is it defined? All right. So let me try to do grep arg list. I see the definition. Okay. I mean, sure, whatever. Um, but I mean, I guess it's fine for like a toy calculator language. It's fine, chat. It's fine. Don't worry about it. It's fine. So it's a linked list, and okay, how do I iterate this stuff? Call str. So arg list, and we also free it. Holy shit. Okay, so this is how I iterate this entire stuff. And how do I get the name? tmp av name. If it's available, one. But I want to have. How can I get the value or something? They also do malloc on it. Oh my god, bro. Oh my god. Honestly, I'm already streaming for 2 hours, right? So I kind of got the idea of what I'm doing in here, right? So, but I kind of like, so we can't pass strings, right? So that's out of the, like, title is out of the equation completely. Maybe we can try to get values at least, right? So, okay, so let's spend some time getting the values. So set gen size and blah, blah, blah. Okay. Yeah, I'm not sure. Count the number of args and add the zeros and ones. So the real question in here is that how then we approach all of that stuff. So some pretend gen string. It's because, like, it gives you the name, but where do I get then value out of this thing? Can't you just set 3? Set 3. Why do I need to set 3? I don't quite get it. Anyways, let me try to do the following thing. I'm gonna just do gdb break bc y, and please break it somewhere at 668. Okay, so I'm gonna run it, and I'm gonna do init window 800 by 600, like so. So we got this thing, and can I print this thing? So history has not, okay, so we can't directly access any of that stuff. So bc c bcc, and just a second, where is that? Oh yeah, so it's this one. Why it's this parameter. Okay, so can I print? It's optimized out. Okay, -1, and yeah, I suppose I won't be able to just easily get this. I can't even get that value, right? So I can't even get that value. Okay, I guess one way you can have Raylib bindings is just by hard coding everything in here. So that's one way you can do that, right? So because you have to deal with their virtual machine. But yeah, interesting. I think I had a little bit of a experience with Yak finally. So yeah, kind of interesting. Yak is not even that bad, honestly. You can kind of get used to all this mess. What if the parameter is passed as a string and then parsed? I don't think so. I don't think they're passed as a string. So can we just... I'm not even sure. So it's a call string. So then star length, sn printf, and s fn. What is fn though? Right, so it's kind of a... Yeah, if they're parsed, if they are parsed, that means they're probably... Yeah, their indices are probably accessed in this generate thingy. That's probably what's going on in here. Okay. So, but we need a function that accepts things. So that means we need to create some sort of a stuff. So Raylib. Okay, so can I just comment out majority of these things? Can I just... Well, it doesn't... It's weird. So I should have read how the comments are done. Is that how we do the comments? Maybe that's how we do them. So we define a function f, a and b, right? And then in here, what do? I just print a and print b. All right, so that's pretty cool. And if I do bc Raylib bc, did it do anything? No, it didn't do anything. But I mean, I didn't even call this function at all. So let's do f34, 35, and let's just like sum them up, something like that. So bc, and it's 69.0. Okay, that's understandable. I wonder if there's a way to mark this function as void so it doesn't return anything, but that's fine, I suppose. One thing we can do is just maybe put a new line so there's something like that. Okay. So let me try to do the following thing. So gen string. I want to now probably put a breakpoint somewhere here. Okay. So let's do GDB break at BCY 700. Okay. So breaking at that, then run Raylib BC. Okay. So let's take a look at the current thing. Again, str. Okay, so this is what we got. I have no idea what the fuck is that supposed to mean though. We can step into that though. All right, did gen true. Okay, did gen compile only, load code. Okay, so, and if I print the code, it is that weird thing. Again, have no idea what the fuck is that. So this is str code, and maybe it makes sense to keep displaying str because we're going to be processing through that. So we didn't have an error, obviously. What is a load string? I have no idea what the fuck is load string. It's some zero stuff. Right, so then switch str, and obviously, right, so currently it is C, and we do add bytes or whatever. Apparently we're adding some. Okay. We consumed the first. I have no idea. This is some. Okay. C1 is the index of the function. Okay, I see. This is some sort of their virtual machine, right? So I have to get very deep into their virtual machine, and I really don't feel like. There is a written C call function, yeah, but I need the arguments. How do I get the arguments? Maybe the arguments are actually, yeah, wait a freaking second. Argument list. Okay. And argument list is expression. If it is an expression, oh boy, I think I know what the fuck is going on in here. You get the arguments as you parse them, actually. Yep. So I'm calling function too early. So it parsed the function call, right? It parsed the function call, but it didn't finish it at like yeah. But I don't know. So this is really BC GUI version. Yeah, that's what it is. That's what it is. But anyway, so let's actually take a look at what we achieved so far. Let's take a look at what we managed to achieve so far. Okay, so this is gonna be Raylib, and oh yeah, so I have to go back to this thing. So let's get rid of this thing. Let's recompile. So compile. All right. Yeah, so this is what we managed to achieve, and this is the result of execution of this script, and this is BC. Right. So I can go for quite some time already, but it's already 2.5 of an hour, so I think that's enough of this stuff for today. Right. I think I got familiar with this calculator well enough, and also looked into its internals. It was actually kind of educational, right? So I learned some things about autoconf and yak out of all of these things, right? It's kind of interesting is that none of that stuff is really needed for such a project, to be fair. Yeah, it is a bit over-engineered, honestly, right? So autoconf is pain in the ass. Using yak also kind of like, it's just like, why do you need additional language yak here? It could have been so much simpler, but I mean, it is what it is. So it also has its own sort of like a weird machine, which is like bytecode is characters. It's kind of weird. And the real question, why the fuck Linux kernel uses that to generate constants? It's so limited, honestly. Right, because you're generating C code. So it's more of a like a string manipulation problem. Right, so it's not a particularly convenient language for doing so. I think like if you need arbitrary math, you probably want to do that in Python, right? So if you can't do that in C because of the arbitrary math, you can do that in Python. Like doing that in Python is much easier. And I'm pretty sure Linux kernel build already depends on Python, does it not? I think it does depend on Python. Does anybody know, right? So who built the Linux kernel? I'm pretty sure it depends on Python already because it depends on a lot of things. So it probably depends on Python. But we can download Linux kernel and just like double check. Raylib math lib for C. There is already arbitrary math lib for C, which is called libgmp. So kernel.org. So let's take a look at the stable tarball. Stable tarball. wget. Isn't that libmath? It's not arbitrary, actually. Isn't there some that? Oh yeah. So there's some like I remember the tweet where I said that there's more Python in Linux kernel than Rust. So so that means the answer is yes, there is a Python in Linux kernel, and because of that, like, what's the point of that time constants? But maybe, by the way, that commit is actually rather old. It's 2013. Maybe they already rewrote that. They could have actually might have rewrote that. We can try to find that specific file. Damn, I forgot that this is a Linux kernel. Okay, just a second. I completely forgot about that. That what I should have done. Oh my god, this is pain. Okay, I should have actually redirected the whole thing into, into def null. Linux redirect def null. Otherwise, it's like I'm gonna be waiting forever. All right, so yeah, so there you go. So we can try to find a file with the name time const, and I'm gonna just put it like that. So this is a file. They're still using BC for this one. It's still there. Look at that. It's still there. It's probably very old code. Even though they already depend on Python, they could have rewritten that in Python. So how many Python scripts do we even have in here? Oh, well, I mean, I just didn't put backslash in here. Yeah, that's why we use things. It's just like this kind of scripts. And it's all kind of, this is scripts, this is tools, right? So drivers and some other stuff. And if you take a look at timeconst, it's inside of the kernel itself, right? So interesting. It's kind of like in a very special place, in a special, very specific place. Like, why BC and not Python directly? I have no idea. All right, so maybe there is a good reason for that. There's always a good reason. But at the same time, it's a very old code. So maybe like at the time when this thing was written, they didn't even use Python at all. So it used to be written in Perl, by the way. So there was Perl scripts in kernel. We can take a look. Is there still any Perl scripts in here? Does it depend on your Perl? Yeah, there's There's still Perl scripts along with Python, so they use both Python and Perl. Yes. Holy legacy, holy shit. Maybe some JavaScript as well, maybe for the documentation. Right, so for the documentation, definitely. Okay, no, well, I mean, wait a second. I keep forgetting that goddamn freaking backslash. No, there's nothing, no JavaScript. No JavaScript. All right, so that was fun. That was interesting, actually. That was interesting. I guess that's it for today. Thanks everyone who's watching me right now. I really appreciate that. Have a good one, and I see you all on the next recreation programming session with Mr. Azuzin. I love you all.